Right, good morning, guys. Just a reminder that I will not be here today or tomorrow. Everything will still go on as normal on both of those days. Remember that your behavior when I'm not here is a test grade, or quiz grade, sorry, not a test grade. So make sure that you are on your best behavior, doing what you're supposed to do, okay? So yesterday we finished up with Math Masters number 20. I also passed back the one that I had taken up for your quiz on 11 through 15. So you should have all of them at this point in time. Any that you were missing, that you weren't here for, that was your responsibility to get. So make sure that if you did not do that this time, that you make sure that you're on top of that for the next set. Okay, so you can have out numbers 11 through number 20 to use on your quiz. They are the pastel yellow colored sheets. That is all that you should have out on your desk at this point. You can have all of those out and your calculator. And here shortly, the sub will be passing out your quiz on numbers 11 through 20. Okay, once you are done with your quiz numbers 11 through 20, please turn it into the substitute and get back in your seat and sit quietly until everybody finishes their quiz. Once everybody finishes their quiz, then you will get your notes and we will go from there. All right, so at this time, we're going to go ahead and pass out that quiz, get you started, and pause the video. And when everyone is finished with the quiz, we'll come back in and jump straight into the notes, okay? Good luck. Make sure you write the correct answer. Make sure you circle your answer so that I can see. Okay, pause the video now and take your quiz. All right, so now everybody should be done with your quiz. We should be moving forward into your notes. Okay, so the sub's going to pass out your template for test 4 lesson 3. Yesterday in class we talked about side, 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 angle, side. And today we are going to talk about angle, side, angle, 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 side, and hypotenuse leg. Okay, these are going to be the 5 ways that you can prove triangles are congruent. So again, yesterday we talked about the first couple. We talked about side, 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 and side, angle, side. Okay, today we're going to move further into angle, side, angle, 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 side, and hypotenuse leg. All right, so let's just get started with our definition here of angle, side, angle. I'll write it first and then I'll read it to you and discuss what it means. All right, so what it's saying here is it's saying that if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then those triangles are congruent. All right, now I want you to pay attention here that the key word here is included side, okay? Notice we have 2 angles, so we're dealing with angle, side, angle here. So angle, the side is in the middle, and then the other angle. All right, so if I had a general triangle here, and I had this angle and this angle, the included side is the side that touches both angles, okay? This side right here, this angle and this angle, here is your included side. It's the side that is between the 2 angles. Okay, both of these sides touch this angle, which is neither of your angles that you're dealing with, so this is your non-included side. Okay, that's your non-included side. Both of those are non-included sides, okay? So you are looking for 2 angles and the side that is between those 2 angles for angle, side, angle congruency, okay? All right, so example number 1. Are the triangles congruent? If yes, you're going to justify that, and you're going to write your triangle congruent statement. Okay, so letter A here, we've got SIT and RUN. or any way you want to put those letters together. Okay, so let's look and let's see what we have. For the first triangle over here, we have two angles and we have the side between them. So that is in fact angle side angle. Do we have the same thing on the other triangle? We do. We have two angles and the side between them. Okay, so we can agree that they are congruent by angle side angle. So now we have to label them. So if I start with angle S here, S to I connects the two angles, and then T would be my third letter. Okay, that means that on the other side, I'm not going to start with R. I'm going to start with N because it corresponds to S. Then that's going to go to the next angle of congruency, which is U, and then we're going to end with R. So triangle SIT is congruent to triangle NUR, and we said that was going to be by the angle side angle postulate. Okay, so your congruency statement is very key here. Make sure that you have the right corresponding parts of these triangles together. Okay. All right, so moving to letter B. Again, I can see right here that I have angle, side, angle. Okay, so I have two angles and the side between them, and I have the same thing here. So we do know that it's going to be angle, side, angle. Okay, so what I need to do now is I need to label my triangles correctly. So if I look at my left triangle, if I start with L and go to G, and then I would be the third letter. Same way if I start with T, I'm going to go to G, and then H would be my third letter. And you can label them several different ways, y'all. In other words, the same one I could label L-I-G and T-H-G. You could go G-I-L, G-H-T. Okay, as long as they correspond to the correct part of the other triangle, you're good. So there's several different ways we could label these. All right, letter C. Again, we've got this angle. We've got the side between it and the other angle. Angle, side, angle. So yes, it is going to be, and let's see what we've got here. Let's label it triangle SLO would be congruent to triangle JAM, and that again is by angle, side, angle. Okay, so for letter D, if you notice here, we're looking at angle, side, angle, right? Okay, so we've got an angle, we've got an angle, we've got angle. Okay, so we've got our two angles. But notice here it is the side between it, but here it is not the side between it. So on this one, on letter D, that's going to be not enough information. Okay, sometimes I will abbreviate that by NEI. Okay, just gives me not enough information without having to write the entire thing out. All right, so letter E here. Okay, I'm going to show you here what happens if we break these apart. Okay, so we do see here that we have the parallel lines, and we do know that if we have parallel lines, then we have a Z right here, alternate interior angles. So we know that these two angles right here are congruent. Okay, same way that you should also, if you don't, you should have parallel symbols here. These are also parallel. Okay, so we can also do these two angles are congruent. Okay, so now we have the two angles. Okay, so if I break these triangles up, I'm just going to show you what happens if I break them apart into two triangles here. Okay, so this will be N, I, C. This will be C, I, and E. Okay, if I do that, then what I have just said is I've said that this angle and this angle are congruent, and I said that this angle and this angle are congruent. And then if you notice, side IC and side IC are the same here, so obviously they are also congruent. So we do in fact have angle side angle. All right, so now we've just got to label our triangle. So we're going to say triangle NIC is congruent to triangle. All right, N corresponds to E on the other triangle. We're going to go to I, which is the red angle for me. So it's going to be ECI. Okay, and that is by angle side angle. Okay. All right, so let's look at example 2 here. They're asking you, what other additional congruence would you need in order to show that triangle QPS is congruent to triangle QRS? Okay, so if I broke these apart, this is what was given, right? Okay, now obviously, y'all, right now, this is the same side in both triangles, so we know that these are congruent. Okay, if you want to do angle side angle, okay, then you would have to know that this angle up here, you'd have to have that angle PQS is congruent to angle RQS. Okay, because then you could do angle side angle, angle side angle. Okay. All right, if you want to do side angle side, okay, you got your two sides. So again, you would have to have angle PQS. Okay, if you want to do that one. Or you could use this side, this angle, and then you would have to know that this side is congruent to this side. So that would mean PS is congruent to SR. You would have to know that for side angle side. And then the other one that we talked about yesterday is side, side, side. Well, we know two sides are congruent right now. And again, the reason, I don't know if I said this earlier, so let me restate this. The reason I know that these two sides right here are congruent is because remember when we talked about triangles, we talked about if their angles are congruent, then the side opposite those angles is congruent. So that's how I could say that PQ and QR are congruent initially, even though it did not label that for my triangle from the get-go. Okay, and then the only other thing that we've learned so far is side, side, side. And again, for that one, we would have to know that PS is congruent to RS. Okay, so that's if they just gave you that general triangle and you were trying to conclude angle, side, angle, side, angle, side, or side, side, side for each one. Okay. All right, so then the second postulate we're going to talk about, or theorem we're going to talk about today, is going to be the angle, angle, side. Okay, so let me fill it in and then we'll talk about it. All right, so what we got here is we've got if two angles and the non-included side this time of one triangle are congruent to two angles and the non-included side of another triangle, then those triangles are said to be congruent. Okay, so what we've got here is we've got a triangle drawn for you. Okay, angle ACB is here and angle CBA is here. So the non-included side would either be side AB, which is the side not between the two angles, or side AC. Either of those sides, if we were given that, side BC is your included side. Okay, it touches both angles, so it is the included side. It's the one between the angles. Okay? So it could be either of those. You could be given AB or AC. As long as they're congruent, then you have angle, angle, side. All right, so let's move on to example number 3. Identify the non-included side for each indicated pair of angles. All right, angle OLI, that's here, and angle IOL is here. Okay, so which side, the included side will be side LO. So the non-included sides would be side LI or side OI. Okay, same thing here. We've got triangle or angle MAG, which is this angle here. We've got angle MGA, which is right here. So included would have been your AG, so non-included are going to be MA and GM. They only touch one angle or the other, not both. Okay, triangle C or angle CAO, so that's right here, and angle OCA, and that's here. So non-included would be CO and AO. Okay, so it's just the ones that do not touch both angles. They only touch one angle or the other. All right, so how do I know which sides are non-included sides? Non-included sides are not friends with both marked angles, okay? So that means this person's friends with this angle and this angle, okay? So they are friends with both of those. This side is not and this side is not. It is only friends with one or the other, okay? All right, page 3, example number 4. Are the triangles congruent? If so, justify and write your triangle congruence statement. Okay, so what we've got here is we have 4 different ways that we can prove it. We've got side, side, side. We've got side, angle, side. We've got angle, side, angle, and we've got angle, angle, side. Those are the 4 that we have learned so far. So we're just going to look at each triangle individually and see what do we know. Okay, now letter A. Already we've got an angle and we know that this side is congruent to itself. So we've got a side there. And it tells me right now that PCH is congruent to HIP. So that means here and here. They are right angles, therefore they are congruent. Okay, so let's see what we've got. If I start here, I've got angle, angle, and then the side. Angle, angle, side. Remember, the side is not between the two angles. So we do know, make your statement that if I start with C, so we'll do CPH is congruent. C corresponds to I, to the non, so IHP to the non-labeled angle. Okay, and we know that by, we said angle, angle, side. Some of these might have more than one possibility. Okay, and that's fine. There can be several, there can be none. All right, so over here, we weren't given any other information, so I cannot assume anything just because it looks like it or whatever. So the only thing I was given here is this side, and that angle right there will be 90 degrees. So I only have one angle and one side. So I have one side, and I have one angle, but I don't have the second side. I don't have a second or a third side. I only have one angle. All right, so this right here is going to be not enough information. Okay. All right, letter C. Okay, right here, remember I know I can go ahead and label that side as congruent because it's shared by both triangles, therefore it's obviously congruent. And I have angle, side, angle. And angle, side, angle. So we're going to label, we'll say triangle BOT is going to be congruent to triangle ATO. And we said that was by angle, side, angle. Okay, letter D. Okay, again, reflexive property, so this side right here is congruent. So if we go, what do we have? We have an angle, and we have a side. So we can either do angle, side, angle, or angle, angle, side. So the question is that side between the two angles or not? It in fact is not between the two angles, so we're going to be angle, angle, side here. So we need to make our congruent statement. So triangle UCT would be congruent to triangle ETC. And that again is by angle, angle, side postulate. Okay. And letter E. Okay, so reflexive property right here, we know that this side is congruent to itself. Okay, so the first thing I'm going to look at is, look, I already have three sides, y'all. So I do in fact have side, side, side. Now, you only have to have one way to prove them congruent. I'm going to show you all the ways that are possible here. Okay, so I've got side, side, side. Well, if the sides are congruent, the angles opposite them are also congruent. So I could even have side, angle, side. I could have angle, side, angle. Or I could have angle, angle, side, because everything in this triangle was congruent. Okay, so therefore I label it any way you want to. Triangle LOV would be congruent to triangle LEV. And you could use any of these. Don't have to use all of them. You can use any. All right, last one of these, letter F. Okay, so this time they have given you that angle FGH is congruent to JGK. So let's see where that is. FGH, that's right here, is congruent to JGK. Okay, it tells us that G is the midpoint of FJ. So we know that's already marked. Okay. FH is parallel to GK. So we know these are parallel to each other. All right. So if those are congruent, that's going to make this one right here 70. Okay. Makes this one 87 and this one 23. So we're looking at those triangles right there. Okay. Now, what we have there is we have these two sides are congruent. So we could have angle, side, angle, or we could have angle, angle, side. Either way. So you have both opportunities there for either one. So we're going to say triangle GFH is congruent to triangle JGK. Make sure y'all can see that there, how I labeled that. GFH goes here, here to here. So that would be JGK. Okay, and we can say that that is by angle, side, angle, or angle, angle, side. Either one. Okay. All right, so that takes us to the very last theorem that we have, which is our hypotenuse leg theorem. Okay, now notice hypotenuse is the side opposite of a right angle in a right triangle. Therefore, we are only dealing with right triangles. So this is for right triangles only. Okay, if the hypotenuse and one leg of one right triangle are congruent to the hypotenuse and one leg of another right triangle, then the triangles are congruent. Okay, right triangles only. So initially when you're looking at this, it either is a right triangle or it isn't. You have to be able to tell that from the get-go. Okay. So let's look and see. Example number 5. Are they congruent by the HL theorem? Okay, well go ahead and look at example letter A. You see they've got a right angle down there, so that is correct. They are right triangles, so that meets our first situation. And then we need a leg. So the hypotenuse, here's your hypotenuse, and here is a leg. So we do in fact have both the hypotenuse and the leg, so we can label these. Triangle GUM is going to be congruent to triangle DRP, and that is by hypotenuse leg. Okay, right here, reflexive property in the middle there, we know that that's congruent to itself. So again, we have a 90-degree angle, we have a hypotenuse, we have a leg. So yes, triangle EHC is congruent to triangle EHO by HL. Okay, letter C. All right, we got the reflexive property right here. So that is the hypotenuse of both of those right triangles. So we do have hypotenuse and a leg, hypotenuse and a leg. So it's going to be triangle CTE is going to be congruent to triangle EUC. Okay, and that is by HL again. All right, so looking at the last one, letter D here. Okay, they're telling you that quadrilateral UGLY is a rectangle. Okay, so then you automatically know opposite sides are congruent. And then in here, we've got the reflexive property for that third side. So you should go ahead and label all three of those. Okay, since it's a rectangle, again, you know, we've got these 90-degree angles here. So we've got this reflexive property here for that hypotenuse, and then you've got either leg would also work. So we are going to say that triangle GUY is going to be congruent to triangle YLG, and that is by hypotenuse leg. Okay, so that takes us to the very last example of your notes today. We've got triangle BCA is congruent to EDA. They want you to use this diagram to explain how we know that. All right, they've given us here, let me make this a little larger so that we can label it. Okay, they've given us here that CA is congruent to DA. They've given us that BA is congruent to EA. All right, and then right here we know, it's not labeled, but we know that this angle and this angle are congruent because they are vertical angles. Okay, so then right there you see that we have side angle side, side angle side. So we're going to say that triangle BCA is congruent to triangle EDA by side angle side. Okay, so we have covered side, 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 angle, side yesterday, angle, side, angle, and angle, angle, side, and hypotenuse leg today. All right, so your homework tonight is worksheet, lesson 4, test 3, worksheet 1. That is a separate video, okay? That video will be uploaded into your Google Classroom. You can go ahead now and get that homework and get started on it. Okay, like I said, that video will be up in your Google Classroom for you to look at. You will tomorrow, you will turn that homework in, and then you will have two worksheets. You'll have a worksheet and a quiz tomorrow. The quiz is just on side, 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 and side angle side. I'm sorry, I take that back. The quiz is on CPCTC, where we prove that corresponding parts of congruent triangles are congruent. And it also includes side, 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 and side angle side. Okay. So that quiz for you will be tomorrow. And then you're going to have test 4, lesson 3, worksheet 2, and a Delta Math tomorrow. We'll talk about all that in your tomorrow video. Okay. All right, so make sure you get your homework done tonight. And like I said, that will be turned in for me to grade once I return. So I will not check that individually tomorrow. You will turn that in as soon as you come into class tomorrow. All right, y'all make sure you behave today and tomorrow, and I will see you all on Monday. But I'll be back tomorrow with another video.